Hi, my name is Kirk Marshall. In this module of Network Security Testing with Nmap, we'll be discussing host enumeration and network mapping. These two phases are highlighted here on the list of Nmap phases of operation that we presented in the previous module. We'll be spending the bulk of this module talking about host enumeration, which is one of Nmap's key processes. We'll also talk about network mapping, or traceroute, which we're taking a bit out of order since it seems to fit better here from a subject matter perspective. Recall that we said that to identify hosts on a network, Nmap sends specially crafted packets to the target host and then analyzes the responses it receives back. The queries are designed to elicit a response from the target system that Nmap can use to deduce information about the target. The objective of the probes during the host enumeration phase is to get a response, any response, back from the target which might indicate that there is a live system at that IP address. To understand Nmap's functionality, we need to delve into the construction and contents of these packets. All network packets are constructed as a series of nested envelopes, or like a stack of Russian dolls. According to the OSI model, the outermost envelopes are the physical and data link layers. Next comes the network and transport layers, and finally, the session, presentation, and application layers. Nmap operates at the network and transport layers, so we'll be focusing our discussion on just those two layers. If you're interested in learning more about the other layers, Wikipedia is a good place to start. The envelope at each layer has a header which contains addresses and other information pertinent to the handling and delivery of the packet at that layer, and then the contents of the packet, which to that layer is just data. Likewise, each nested envelope has its own header and data sections. Let's discuss the network and transport layers. The network layer is responsible for the movement or routing of packets across the network. On the Internet protocol is the protocol in use at the network layer. The header for an IP packet is laid out like this. Each line represents 4 bytes of data, so the IP header is a minimum of 20 bytes long. The fields of importance to Nmap are the flags and fragment offset fields, and the source and destination IP addresses. We'll be discussing the two flags, which pertain to fragmentation, and the fragment offset field later in the course when we talk about firewall evasion techniques. The source IP address is most often the IP address of the local interface from which we're sending the packets, but can be set by Nmap to other values too. The destination IP address is, of course, simply the target.